Hello dear students, welcome to this session 4 of discussion on the nuclear physics chapter. So in the previous 3 sessions we have discussed about the basics of nuclear physics and radioactivity, and after that we have also discussed in detail about the alpha radiations. In that we have discussed the properties of alpha radiation, the theory of alpha decay, the range and energy of alpha decay, ionization and specific ionization of the alpha decay, and after that we have also discussed one of the relation between the range of alpha decay and the decay constant in the form of one law which is known as Geiger-Nuttall law. In this session we will try to discuss, or we will try to understand about the next type of nuclear radiation, that is beta radiation or the beta rays. So in this we will discuss about some the introduction part of this beta radiation, means which particle is generally considered as the beta particle, then what are the properties of this beta radiations, then types of beta decay, and at last the Fermi's theory of beta decay, which explains the continuous spectrum of this beta decay. So in this nuclear physics, beta decay is a type of radioactive decay in which a beta particle, so that beta particle may be either electron or positron. So positron is nothing but the antiparticle of that electron. It means the properties of that positron are all same in comparison with the electron, but the only difference here is it is having opposite charge of that electron. So electron is denoted by E minus, whereas the positron is denoted as E plus. So in this beta decay, the emission of beta particle, so that may be either electron or positron, is emitted from an atomic nucleus which transforms the original nucleus to an isobar of that nuclei. So isobar means the proton number and neutron numbers are interchanged, but the mass number remains same. Or else, in other words, or in most simplest way, we can define this beta decay as the conversion of one type of nucleon into another type. So we all know the protons and neutrons are called as the nucleons. So conversion of one type of nucleon into another type of nucleon is called as beta decay. So that conversion may be proton is converted into neutron, or neutron is converted into proton. So these are the two possibilities. So in this beta decay, what happens? One nucleon is converted into another nucleon. Then what are the properties of these beta rays? So a beta minus particle means a electron is simply a beta minus particle is simply an electron which has been expelled from the nucleus, which is emitted from the nucleus. So the electron is not existing in that nucleus because of that conversion of neutron into proton, and due to that charge conservation property, in that conversion process the electron is emitted. So that is beta minus decay or negative beta decay, in which a negatively charged particle is emitted, and a beta positive particle, or we can call it as positron, is essentially an electron with positive charge. So it is opposite of that electron. The other properties are same, only difference is charge, whereas electron is negatively charged and this positron is the positively charged particle. So if we look at the charge of this electron or positron, then it is having, in the negative case, it is minus 1.6 into 10 raised to minus 19, that is beta minus, and in the case of beta plus, it is 1.6 into 10 raised to minus 19 coulomb. So charge is same, means the value is same, the charge sign is opposite. One is negative and another one is positive. Then both particles have the same mass, that is about 0.00055 unified atomic mass unit. Then these beta particles moves with velocity almost equal to velocity of light, that is near c. Then in comparison with the alpha particle, these beta radiations are penetrating, means they have a more penetration power than the alpha particle. And as these beta particles are charged particles that may be positive or negative, so when we place a radioactive source which is emitting beta particles in electric field or in magnetic field, it will show deflections, means negative particles are attracted towards positive plate, whereas the positive particles are attracted towards the negative plate. So these are the some of the properties of these beta radiations. Then if we want to understand what are the different types of beta decay, so initially we have defined beta decay is nothing but conversion of one type of nucleon into another type of nucleon. So that is neutron is converted into proton or proton is converted into neutron. So based on that conversion, we have different types of beta decay. So the first one is beta minus decay. If you look at this schematic representation of this beta decay, here we have parent nucleus which is converted into daughter nucleus, means with the emission of certain particle it is converted into daughter nucleus. Then if you look at the general representation of these two nuclei, parent nuclei is represented as the chemical symbol X, mass number is A and atomic number is Z. And after undergoing this beta minus decay or negative beta decay, the daughter nucleus has chemical symbol Y, mass number same, that is A, and atomic number is increased by 1 unit, that is instead of Z we have Z plus 1. So proton number is increased by 1, means the neutron is converted into proton. So in beta minus decay what happens? Neutron is converted into proton. The mass number remains the same, means Z is increased by 1 unit, means N is decreased by 1 unit. So Z plus 1 and N minus 1. So in this process and due to that charge conservation, neutron is converted into proton. So neutron is neutral particle. So on right hand side we have 0 charge, but on left hand side as it is converted into proton we have 1 unit of positive charge. So because of that charge conservation along with that proton, because of that charge conservation, so with one positive charged particle there will be emission of one negatively charged particle. So and that negative particle is known as beta minus particle or the electron. So what happens in this beta minus decay? Neutron is converted into proton with the emission of electron. So in this process not only electron is emitted, along with this electron there will be emission of one elementary particle which is called as anti-neutrino. So why this anti-neutrino or neutrinos are emitted in this beta decay we will discuss later. So in this beta minus decay, that is first type of beta decay is beta minus decay. In this process neutron is converted into proton with the emission of electron and the anti-neutrino. So this is first one. Then the second one is reverse of this, that is beta plus decay. In the previous case neutron is converted into proton. In this case the reverse, means proton is converted into neutron. So because of that proton is converted into neutron, means on the right hand side we have charge plus 1 unit, that is proton. Then on left hand side neutron is neutral. Again because of that charge conservation, along with that neutron 1 unit of positive charge is emitted, that is nothing but E plus, that is positron, means antiparticle of electron. The remaining all properties are same, but charge is opposite. So in beta plus decay, proton is converted into neutron with the emission of positron. Along with that positron, here also one of the elementary particle is emitted, that is known as neutrino. In the previous case it is antineutrino, and in this case it is neutrino. So this is second type of beta decay, that is negative beta decay and the positive beta decay, beta minus and beta plus, that is depending upon the charge of the emitted particle. If it is negative, that is electron, it is beta minus decay. If it is positive, that is positron, it is known as beta plus decay. Along with these two dominant process, there is one more process which can occur with least probability, and this third type of beta decay is called as the electron capture. So the name itself suggests electron capture means the proton captures one of the electron and converted into neutron. So in this electron capture, proton captures one of the electron and converted into neutron. So here we have represented the general representation. So we have parent nuclei which is denoted with chemical symbol X, mass number A and atomic number Z. So this nuclei or the one of the proton of this nuclei captures one electron. So because of that positive charge and negative charge, it becomes neutral. So proton is converted into neutron. So these are the three processes. One is beta minus decay. Neutron is converted into proton with the emission of electron and antineutrino. Then the second one is beta plus decay. Proton is converted into neutron with the emission of positron and neutrino. Then the third one is electron capture. In this process, proton captures one of the electron and converted into neutron. So these are the three types or three different types of this beta decay process. So we will consider some of the examples for these three processes. So the first one about beta minus decay, the carbon 14 nucleus undergoes beta minus decay. So carbon 14 means, if you look at the periodic table, the carbon has atomic number is equal to 6. So proton number is 6 means neutron number is 8. So that mass number is equal to 14. So after undergoing beta minus decay, it is converted into nitrogen 14. So nitrogen is next to that carbon. So it is having 7 protons. And total number of nucleons is 14 means, so 14 minus 7 means it is having 7 neutrons. So carbon 14 having 6 protons and 8 neutrons. It is converted into nitrogen 14 which has 7 protons and 7 neutrons. Means in this process 6 protons becomes 7 protons, whereas 8 neutrons becomes 7 neutrons. So neutron is decreased by 1 and proton number is increased by 1 unit. So in this conversion, the electron and antineutrinos are emitted. So this is one of the example for this beta minus decay. Similarly, for beta plus decay, consider carbon 10. So again, the carbon 10 means its atomic number is same, that is 6. So proton number is 6 means 10 minus 6, that is 4 neutrons. It is converted into boron 10 by undergoing beta plus decay. So boron is before this carbon. So it is having atomic number 5. So 5 protons and 5 neutrons. So in this process, what happens? 6 protons has been reduced to 5 protons, whereas 4 neutrons has been increased to 5 neutrons. So neutron is increased by 1 unit and proton is decreased by 1 unit. So proton is converted into neutron with the emission of positron and neutrino. So this is the example for this beta plus decay. Then similarly for electron capture, that is third type of beta decay, So in this krypton 81, which is having 36 as the atomic number, means 36 protons. So it captures one of the electron and it is converted into bromine 81. So here 36 protons is reduced to 35 protons. So by capturing one proton, by capturing one electron, that proton has been converted into neutron, again with the emission of neutrino. Similarly, the next one, that is Cm239, having 96 protons, captures one electron and it is get converted into americium 239 with the proton number 95. So 96 protons has been reduced to 95, means one proton captures one electron and gets converted into neutron with the emission of neutrino. So these are the some of the examples for these three different beta decay process. One is beta minus decay, beta plus decay, and the electron capture. So in all these three processes, along with the negatively charged particle and the positively charged particle, some of the elementary particles such as neutrinos and antineutrinos are emitted. So why this neutrino or antineutrino is emitted in this process? So we will discuss here. So in the 1934, the scientist Fermi developed a theory to explain the continuous beta ray spectrum. So if you look at the spectrum of this beta radiations, it is continuous, it is not discrete, means the one particle is emitted and it is having certain fixed energy, so that we will get one peak, so that is discrete manner. But this beta decay is not having a discrete spectrum and it is having continuous beta ray spectrum. So it was explained by the scientist Enrico Fermi in the year 1934. So in order to explain this continuous beta ray spectrum, he proposed a theory or hypothesis which is called as neutrino theory. So this theory is called as neutrino theory of beta decay. According to this theory, the total energy is shared between the beta particle and the neutrino or antineutrino. So in this beta decay process, whether it is beta minus decay or beta plus decay and the electron capture, the amount of energy released, the total energy is not carried by that emitted beta particle, that may be electron or positron. So the total energy is not carried by that beta particle. So there will be certain amount of missing energy. So that missing energy will be carried by these elementary particles, that may be neutrino or antineutrino. So because of this reason, the total energy of these two particles is a constant. So the maximum energy or total energy is shared between these two particles. One is beta particle and another one is either neutrino or antineutrino. So the total energy of these two particles is a constant which is equal to end point energy. So the end point energy is nothing but the maximum kinetic energy or the total amount of energy released in the beta decay process. As the beta particle is not carrying the total energy, there will be certain amount of or some amount of missing energy, and that missing energy is shared between this beta particle and the neutrino or the anti-neutrino. So consider one of the example here. So this is the continuous beta spectrum of bismuth 210 radioactive source. So bismuth 210 radioactive source undergoes beta decay and the spectrum of that beta decay is in this manner. So here the intensity or number of counts is plotted along y-axis and energy in terms of mega electron volt is plotted along x-axis. Then if you look at the spectrum or this continuous spectrum, the electron or the beta particle carried only 0.4 mega electron volt energy. So that is the first line in this graph which is drawn parallel to y axis. So that is the amount of energy, that is 0.4 MeV electron. So electron carries only 0.4 MeV energy, but in this beta decay process, that is beta decay of bismuth 210, the energy released is about 1.16 MeV. So electron carries only 0.4 MeV, but the total energy released is 1.16 MeV. So the difference between that 1.16 and 0.4, that is about 0.76 MeV. So that much amount of energy is carried by the neutrinos or the antineutrinos. So because of that reason, the missing energy is carried by these elementary particles. So from this we can understand that why the neutrinos or antineutrinos are emitted in this beta decay. The reason for this is the emitted beta particle does not carry total energy released in that process. So because of this reason, there is a part of missing energy, and that missing energy is carried by the elementary particles such as neutrinos or antineutrinos. So because of this reason, we get the continuous beta ray spectrum but not the discrete beta ray spectrum. So because of this energy conservation, along with beta particle, the neutrinos or antineutrinos, which are called as elementary particles, will be emitted in this beta decay. Then in order to explain some of the properties of these neutrinos or antineutrinos, the scientist Pauli given a hypothesis which is known as neutrino hypothesis. So during the beta decay of the nucleus, energy and spin angular momentum is not conserved. So during this beta decay process, energy and spin is not conserved. There was some missing energy in the reaction. So this was explained by the scientist Pauli, who gave a hypothesis that during beta decay, one more particle called neutrino is emitted along with the electron. So in order to conserve that total energy, or in order to conserve that, means in order to carry that missing energy along with the electron or positron, there will be emission of one more particle in this beta decay, and that particle may be either neutrino or antineutrino. So this neutrinos or antineutrinos will carry the missing energy. Then what are the properties of this neutrino or antineutrino? Means the neutrino has zero charge, negligible mass, and spin is equal to half. So this neutrino is chargeless particle. So antineutrino means it is antiparticle of this neutrino, just like positron and electron, where positron is the antiparticle of electron. So as neutrino has zero charge and its mass is negligible, and spin of this neutrino is exactly equal to half. So during the beta decay process, there are two types of neutrinos are emitted. One is neutrino emitted along with the positron when a proton changes to a neutron. So that is beta plus decay. And the other is antineutrino emitted along with the electron when a neutron changes to proton. So when proton changes to neutron, the positron and neutrinos will be emitted, and when the neutron changes to proton, electron and antineutrinos will be emitted. So in this class we have discussed the properties of beta radiations, then types of beta decay, that is beta minus decay, in which neutron is converted into proton with the emission of electron and antineutrino. The second one is beta plus decay, proton converted into neutron with the emission of positron and neutrino. And the third one is electron capture, in which proton captures one of the electron and converted into neutron with the emission of neutrino. Then some of the examples for these three different beta decay process. So in this beta decay, along with the electron or positron, the other elementary particles are emitted. In order to explain why those elementary particles are emitted along with those, the electron and positron, the scientist Enrico Fermi given a theory which is known as neutrino theory or Fermi's theory of beta decay. So why those elementary particles are emitted? In order to conserve the charge or in order to carry the missing energy. So for that we have considered one of the example, that is bismuth 210 decays through beta decay process, in which the beta particle carries only 0.4 MeV charge energy, whereas the total energy released in that process is about 1.16 MeV. So the missing energy, that is about 0.76 MeV, is carried by the neutrinos. So that is the example for that Fermi's theory of beta decay. And the beta decay has the continuous spectrum. Why it is continuous? Because of the energy shared between the beta particle and the neutrinos. Then in order to explain some of the properties of this neutrino, Pauli given a theory or hypothesis which is known as neutrino hypothesis. So these neutrinos have zero charge, negligible mass and spin is equal to half. And during the beta decay process, the two types of elementary particles will be emitted. When proton is converted into neutron, the neutrino will be emitted, and when a neutron is converted into proton, the antineutrino will be emitted. So with this we have completed this beta decay process, that is properties of beta radiation, Fermi's theory of beta decay and the neutrino hypothesis. So in the next class we will try to understand, or we will have the discussion on the different nuclear models. Thank you.